All right, let's jump right into this explainer. Today we're going to completely unpack how to navigate and conquer the SuperCloud Composer network module, pulling straight from the version 3.1.0 user guide. Look, if you're managing a modern data center, you already know that network complexity is, hands down, one of the biggest bottlenecks to scaling efficiently. So we're going to explore exactly how SuperCloud Composer, or SCC, untangles all that complexity, giving you this incredibly powerful single pane of glass to manage your entire disaggregated infrastructure.
We've got a fun macro to micro journey lined up for today. We'll start by meeting SuperCloud Composer, then look at managing at the macro level, zoom into drawers and appliances, configure our ports and VLANs, explore network provisioning, and finally, wrap up by mastering blade enclosures.
Okay, let's kick things off with Section 1, Meet SuperCloud Composer. So, the absolutely crucial thing to understand here is that SCC uses centralized network provisioning wizards to push JSON-formatted build plans to single or even multiple switches simultaneously. You aren't just stuck configuring one switch at a time in a vacuum anymore. You're actually creating standardized templates and orchestrating them across your network using industry-standard API calls. And to keep everything running perfectly smooth, SCC relies on this really intelligent network agent called the switch sweeper. It essentially runs in the background to guarantee your operational configurations actually match those original build plans.
Now, what's really cool is that whether you're running Supermicro switches or mixing in other brands, SCC gives you comprehensive top-of-rack management capabilities across the board. You aren't locked into some proprietary walled garden just to get basic network visibility. You're getting interface statuses, MAC address details per VLAN, full switch configurations, and network topography views, completely regardless of whether the hardware actually says Supermicro on the bezel or not. It's really all about true, unified management.
Moving right along to Section 2, Managing at the macro level.
If you're a sysadmin, you are going to love this. You have the power to easily manage firmware updates across the entire rack in just 3 snappy steps, using the function group bar. No more jumping through hoops or having a dozen terminal windows open. You literally just grab the switch from your list, point to the firmware file, which can be locally uploaded or already sitting on your server, and hit the option to automatically restart the switch post-update. It takes a historically tedious maintenance task and turns it into a totally frictionless workflow.
And while you're viewing switch details at this high level, you can effortlessly identify your LLDP neighbors. Link Layer Discovery Protocol is basically your best friend when you inherit a complex network, right? SSECC gives you a dedicated view to instantly see the identity and the capabilities of adjacent devices. So you don't have to guess how the fabric is physically cabled. The protocol tells you exactly who is sitting next door.
All right, let's get a bit closer in Section 3, zooming in on drawers and appliances. When you click into a specific drawer, SCC hits you with this immediate, highly detailed visual schema, showing you both front and rear views, right alongside vital stats like system uptime and operational state. It's all presented in this really slick, dynamic carousel view that instantly tells you if the system is healthy. You get all your critical metadata at a glance: IP and MAC addresses, the exact SKU, firmware versions, even credential management. It just perfectly bridges that gap between your physical hardware and digital management.
Okay, Section 4, Configuring Ports and VLANs. Let's get our hands dirty.
Now, your MAC address table or CAM table is absolutely your best troubleshooting tool here, but you've got to remember to refresh it. Why? Because the SCC fabric is always dynamically updating. The Ethernet switch builds this table on the fly by looking at the source MAC addresses of the frames it receives. Anyone who's ever chased down a rogue MAC address knows that network topologies shift rapidly. Looking at stale data is just going to send you down the wrong path. SCC even lets you filter this table by VLAN ID, so you can isolate exactly where that rogue device might be hiding.
When it comes to physical port settings, making modifications is incredibly fast. But here's a great built-in safeguard. Your MTU fields will actually be disabled unless the admin status is specifically set to down. So once it's down, you can easily jump in, toggle flow control, and dial in your maximum transmission unit, as long as it's a valid number between 1500 and 9216. The GUI is really designed to catch those simple, silly configuration errors before they can bring down a link.
Next up, Section 5, Network Provisioning Made Simple.
We really need to highlight the distinct difference here between standard compute provisioning and storage switch provisioning. While your standard compute switches just need basic JSON build plans, storage switches are, well, a whole different beast. Data center storage demands incredibly high throughput and ultra-low latency. That means your switch has to be configured to respect those intense traffic demands using specific DCBX, or Data Center Bridging Exchange, parameters.
So why do storage switches need those extra parameters? It's all about supporting RDMA and ROAST fabrics to maintain flawless communication between targets and Ethernet switches. RDMA, or Remote Direct Memory Access, literally allows one computer to read memory directly from another without even bothering the operating system. To pull that off over Ethernet, the network absolutely must have lossless queues and strict flow control. The awesome thing is, SCC's Storage Fabric Configurator Wizard builds these exact parameters into the JSON template for you automatically. Actually creating your VLAN build within the Configurator Wizard is a highly structured, totally error-proofed process. It guides you step by step. First, pick a valid VLAN ID. And no, it won't let you use reserved ones like 4050 or duplicate one you already have. Next, you give it a name. Then, as you select your Baseboard Management Controller, or BMC, along with your LAN 1 and uplink ports, SCC actually draws highlighted boxes around the interfaces right on your screen. You visually know exactly which ports belong to which VLANs. It leaves literally zero room for guesswork.
So, as we reach the most microscopic level of our journey today, it begs a bigger question. Why exactly is the data center industry trending so heavily toward blade enclosures? What's driving this massive shift away from traditional rack mounts? And more importantly, how does SuperCloud Composer handle it?
Which brings us to our final stop, Section 6, Mastering Blade Enclosures.
Think about it. Traditional 1U pizza box configurations just eat up space and power. When you stack standard 1U servers, you're constantly duplicating power supplies, cooling fans, and bulky metal chassis. But by stripping servers down to blades and sliding them into a dense enclosure that shares power and cooling, you drastically lower your facility's power requirements and massively improve your power usage effectiveness. Plus, SCC supports zero-touch provisioning, or ZTP, for these Ethernet blade switches, which means you can deploy them rapidly without any manual console configurations. It's a real game changer.
To put this into perspective, Supermicro superblades use this incredibly sleek, integrated architecture. The network interface controller on the blade physically connects directly to the electrical traces on the chassis midplane. Those traces act as the downlink ports for the internal switch. From there, the physical ports on the front bezel of that switch module act as the uplink ports, running the physical cables out to your broader data center network. SCC natively understands this internal versus external hierarchy, letting you configure the whole shebang seamlessly.
So, with the power to provision an entire disaggregated infrastructure right from a single pane of glass, how will you use SuperCloud Composer to revolutionize your daily network operations? We've gone from a massive multi-rack macro view all the way down to the internal mid-plane traces of a single blade server today. The tools to eliminate configuration errors, automate deployments with JSON templates, and gain total visibility are all sitting right there waiting for you. Thanks so much for joining me on this explainer. Keep exploring, keep optimizing, and we'll see you next time.